Returning from that review video on partial fraction decomposition, in particular for this very integral, we can just write out the solution now. So the solution ended up being 1/3, and it was natural log absolute value of y over 3 minus y. And that still equals t plus c. And so the first thing actually is this solution here isn't able to solve for all different initial conditions. So you can see that if you look very carefully, that if y equals 0, which is one of the solutions, we end up with natural log of 0 over 3 minus 0. Well, that's 0. Natural log of 0 is undefined. And it's like negative infinity. So this actually won't capture the y equals 0 solution. Let's just go ahead and look at that. So one solution we have is y of t is equal to 0. And that is definitely a solution. So if I take the derivative of 0, it's 0. So I get 0 in the original ODE. And if I plug in 0 for y of t, I get 0 times 3 minus 0. Well, that's 0, and 0 equals 0. So this is a valid solution. Another valid solution is y of t is equal to 3, which also doesn't work with the solution we found, because we ended with a division by 0. We end up with 3 over 3 minus 0. So that doesn't look like it's captured very well in this equation. But this is also a solution, right? So dy dt, 3 prime, is 0. And then if I plug in 3 to the original ODE, I end up with 3 times 3 minus 3. Well, that's 0. And yeah, 0 equals 0. This is another solution. So then this will be a third solution. And sometimes you can end up with kind of different things in different regions, but it turns out one equation is going to be handle all three of them, even though they look pretty different. So let's go ahead and find that and get going here. So we have, right, so first thing I want to do, I have this equation, I want to get rid of the 1/3, so I'm going to multiply everything by 3. So we have natural log absolute value of y over 3 minus y is equal to 3t plus c, plus 3c. But that 3 I can lump into the constants. That ends up being 3t plus just a constant. Next I want to exponentiate to get rid of the natural log. So take the e to the natural log cancels, and I end up with absolute value of y over 3 minus y equals e to the 3t plus c. But I can also write that right as e to the c times e to the 3t. Then e to the c is another constant, so I can just write that as constant times e to the 3t. Okay. Now the next bit is, right, depending on the value of y, this is either going to be positive itself or negative itself. And you can kind of lump that into the constant of integration. So, right, so the constant will be whatever it needs to be to satisfy this absolute value to make sure it comes out correctly. And so we can essentially, right, drop the absolute value and put the plus minus into the constant. So really we only have to solve for y over 3 minus y is equal to some constant, it's kind of plus or minus e to the 3t, and that's still just some constant times e to the 3t. Right, so now for the fun part, we got to solve for y, and let's go ahead and start doing that up here. So now I have y over 3 minus y is equal to c e to the 3t. So I'm going to multiply everything by 3 minus y, and then split up things and solve for y and all that fun stuff. So I have y equals 3 minus y times c e to the 3t. I'm going to expand that out, so I have y equals 3c e to the 3t minus cy e to the 3t. One thing to note here, I can't just lump this 3 in with the c, because even though it's a constant, and 3 times a c is a constant, this c is also a constant, and they have to be the same constant. So the c right here and the c right here have to be the exact same constant. So I can't change one of the c's without changing the other. They're the exact same constant. So just keep that in mind. I can't absorb that 3, and be careful in the future when you are doing that. But all right, here we go. So next step, I have, let's see, I'm going to get the y's on one side, so I'm going to move this over to the left-hand side. So I end up with y plus cy e to the 3t equals 3c e to the 3t. Then I can factor out the y, so I have y times y, 1 plus c e to the 3t equals 3c e to the 3t. Then I can divide, and I have y of t equals 3c e to the 3t over 1 plus c e to the 3t. Now I can make this a little nicer as well. It's usually nice to have the constant in just one place rather than 2 or 3. So if I multiply everything by 1 over c on the top and bottom, then that ends up, so this 1 over c times that c cancels, so I have 3 e to the 3t. On the bottom, I end up with 1 over c plus c e to the 3t. Oh, sorry, plus e to the 3t, the c's cancel. But I can also write 1 over c as a constant. So I have 3 e to the 3t over c plus e to the 3t. And that's actually going to be our third solution here. So maybe we have y of t equals 3 e to the 3t over c plus e to the 3t. And amazingly, that actually will handle the cases when y is less than 0, when 0 is less than y is less than 3, and when 3 is less than y. And there we go, we're done with this separable equation.